So, see, we've been talking about graphs and curve sketching and all these sorts of things. Let's have a look at a general idea of sketching polynomials in general, things to watch out for. Now, obviously, the y-intercept is always going to be the constant. It doesn't matter what the polynomial is, because, of course, when you substitute 0 into all the x's, you're just going to be left with a constant. So, as an example, I'm going to sketch this particular polynomial. Now, we don't need to expand the whole thing out to work out the constant. We just look at the constant. So I'm going to have 1 times minus 1 cubed times 2 squared, which is, of course, minus 4. So let's plot that in. There it is down there at minus 4. Okay. X-intercepts are the solutions to the equation. Now, if it is possible to find them, we find them. And of course, my one is because I've got it factorised. So we know the x-intercepts. There's one at minus 1, then another at 1, and another at minus 2. Okay. Now, what happens out at infinity? The leading term will what we call dominate out at infinity. So if we want to know what a polynomial is doing out at infinity, all we need to do is look at the leading term. And whatever that's doing, this curve will be doing. So we know where to start and finish, if you like. So let's have a look at ours. Our leading term is going to be x times x cubed times x squared, which gives me x to the power of... Now, if I was just to ask you to draw x to the power of 6, you would have a U shape. So we know this particular polynomial will start up here in the third quadrant and finish over here in the first quadrant. So start up there, finish over there. Yeah. Now, roots always behave like the power. So once you've factorised a polynomial, you have a look at the factors. And if it's an even power, then it should hit that, well, it won't be an x-intercept because it'll just touch it, like a U shape. So here we've got x plus 2 squared. That means at negative 2, I know it's just going to touch negative 2 and come back up like a parabola. It will act like the power. So that factor is x plus 2 squared, which would be a parabola. We know we start up here, so at negative 2 it must be doing that sort of U shape there. And similarly, odd powers will always look like the twisting shape. Other than the power of 1, of course, because power of 1, it would look like a straight line, so they just cut straight through if a power is 1. So where is it? There it is, x minus 1 all cubed. So over here at positive 1, I know it's going to come through like a cubic. So if it finishes up there, then it must do that sort of shape at 1. And as I say, negative 1, well, it's the power of 1, x plus 1 to the power of 1, so it'll just cut through it like a straight line. So I know this polynomial will start up here, it'll touch at negative 2, then cut at minus 1, it'll come through negative 4 on the y-axis, then it will inflect at 1 and finish at the top. That's enough information to get a rough sketch. Well, that's not a rough sketch, that's an exact one. I cheated and did it exactly there on a graphing package. At this stage, whether that turning point's on the left-hand side of the y-axis or on the right-hand side, don't really know. It's more guesswork at this stage. Once we look at some calculus, we can work out that exactly where that's going to turn from. But to get a rough sketch of what a polynomial is going to look like, that's not bad. Not a bad way of doing it. Just looking at those particular features. Now, if it can be factorised perfectly, then it will just look like the basic curve. So if you had x minus a to an even power, we know it would look like a U shape. If we had x minus a to an odd power, then we know it will look like an inflecting sort of curve. Sorry if I'm boring you. There. Let's solve this inequality then, because we can use the idea from solving quadratic inequalities to really any sort of inequality if we can factorise it. So I've got x minus 1 squared times x plus 3. So if I was to draw that graph, okay, I've got an x-intercept at 1. I know it's just going to touch at 1 because it's like a parabola. Over at negative 3, it'll cut through at negative 3. The leading term is x cubed. If I was to draw y equals x cubed, it would start up here, finish down there. So something like that. I'm saying, when is this curve less than or equal to 0? So if I look at the picture, when is it below? Well, there it is, -3. Don't forget the single point 1. It is touching there. So it is equal to 0. Right? So when is it below? Bang, over there. So there's my solution. X is less than or equal to -3, or x is equal to 1. So we can, as I say, use that similar idea that we saw with quadratic inequalities and really apply that to any sort of polynomial inequality. All right. So that's 3B.